So to help you get a feel for this, I have given on this video several examples, just several examples of angles. So this theta 2, remember theta 1 I was going counterclockwise. This theta 2 has the same initial and terminal sides as the one on the previous video, but now I'm measuring it clockwise, 1 revolution clockwise. And so clockwise means it's a negative angle, and I'm going all the way around the circle once, which is 2 pi. So it's going to be negative 2 pi. That's that angle there, marked by the purple arrow. Now you can go around several times. So here what I've done is I've gone, let's see, I've gone around. From here I went around once, twice. Yeah, twice. And I'm going counterclockwise. So I've traveled around this unit circle 2 times from here. 1, 2, counterclockwise, so it's positive. Going around 2 times, that's going to be 4 pi. So that angle is 4 pi. Notice it has the same terminal side and the same initial side. So the initial side and the terminal side don't determine what your angle is. If you're accustomed to triangles, you might think that it does, but that's because you're measuring interior angle of a triangle. We define it to be positive, and we define it to be the smallest possible measure for that angle, smallest positive angle. So it's just a special case. So we're generalizing from the special case. So that's theta 3 there is 4 pi. Okay, now I'm going to go halfway around. Counterclockwise is positive. My terminal side is now on the negative c-axis, negative horizontal axis. I'm going counterclockwise, so it's positive. All the way around would be 2 pi, so halfway around is pi. It's 1/2 of 2 pi. Right? So that's pi. That's a really important thing to remember. Going halfway around the circle, it's like 180 degrees is pi. Pi radians. Okay. Okay, here, same initial and terminal sides for the angle, but I'm measuring it differently. I'm measuring it clockwise, so that's going to be negative, and it's halfway around the circle, so it's half of negative 2 pi, so it's negative pi. So that's negative pi. Okay? And I'm going to break it down into different, these are just really common angles that we use all the time, so they're good to know. Theta 3 is an illustration that you can go around several times before you settle onto the terminal side and get different numbers for the angle, for the measurement of the angle. You might wonder why we want to do that, but there's a reason. What's going to happen is our angle is going to end up being any real number, and that's why in order to do that we have to allow it to keep going around and around and around the circle as many times as we wish, basically. Otherwise everything would be between, say, negative pi and pi, or maybe 0 and 2 pi, and everybody would have to agree on it, and it would cause complications when you do computations because there'd be endpoints where you don't want endpoints to be. So theta 6, here I'm going counterclockwise, so it's positive, and it's 1/4 of a circle, or if you want, it's 1/2 of where pi is. Remember the angle pi over here, I'm just doing half of that now. So it's pi over 2, 1/2 pi, right? Pi over 2. So that's a good one to remember. Pi over 2 is 90 degrees. That's a 90-degree angle. Pi over 2. Now this one I'm going clockwise, so it'll be negative, and I'm going pi, negative pi from here to here, and then an additional negative pi over 2. So if you add those, you get 3 pi over 2. You could also do it this way. negative pi over 2, negative 2 pi over 2, negative 3 pi over 2. Just count how many pi over 2's you have. That's a kind of an easy way to do these. So that's negative 3 pi over 2. Okay. Now this one here, theta 8, is half of pi over 2. Remember pi over 2 here, theta 6, theta 6. That's pi over 2. This is pi. All the way around is 2 pi. Halfway around is pi. Quarter of the way around is pi over 2. Half of that is pi over 4. So that angle in radians is pi over 4 if you measure it from here to here. So it's pi over 4. That's used a lot. Okay, now this one is 1/3 of pi over 2. 1/3 of pi over 2 is 1/3 times pi over 2, which is pi over 6. Right? Pi over 6. Maybe you can see there's actually 6 of these if you go from here to here. There's 1, 2, 3, 4, 5, 6 angles this size going from here to here. So that's pi. So this is pi over 6. So it's 1/3 of this quadrant 1. Remember, this is the quadrant 1 is from here to here. So it's 1/3 of it. And then this one is 2/3 of that quadrant. So this is twice as far as theta 9. So this is 2 pi over 6, which is pi over 3. And you might notice this is pi around to here, right? Is pi. So there's one over here that's 1/3 of pi, right? This is 1/3 of pi, so there's another one here that's 2/3 of pi, or 2 pi over 3. And then there's 3/3 of pi, which is just pi. So this is divided, if you think of this as the circle is divided into 3 parts, the upper half is being divided into 3 parts. Each of those parts is 1/3 pi. So that's 1/3 pi, 2/3 pi would be here, and 3/3 pi, which is pi, would be here. Okay, so that's just to kind of orient you on how this all works. You should be able to figure out where negative pi over 6 is, the angle negative pi over 6, negative 5 pi over 6, or 5 pi over 6, and etc. Just using the reasoning here. You're not memorizing all of these. You're reasoning it out until you comprehend. And then you don't have, because there's infinitely many of these that you can memorize. And you don't want to do that. I've seen sometimes people will have, when they're trying to show students this, they'll have a chart with this circle divided into I guess it would be 24 pieces, and then they have each one labeled, and they think that the student has to memorize each one. You're not memorizing each one. You're just comprehending what's going on, and then you can figure out whatever we give you. Okay? And so use these 4 examples that way, not as something to memorize, but as something to comprehend. And that will get you a lot further.